In this video, we present our work that has been accepted for presentation at RCCV 2021 conference, SLOTR, Slaughter Attention-Based Classifier for Explainable Image Recognition. SLOTR is a classifier that can output classification decisions as well as the visual explanations at the same time. There are two kinds of SLOTR. The first one is the positive SLOTR that is used to find the positive reasons for each category. For example, positive SLOTR can find the reason for this board being the red face camerad, that is, the region of the red face. The second kind of SLOTR is the negative SLOTR, which is used to find the negative reasons for categories. For example, for this 7 being not category 1, negative SLOTR gives us the region of the horizontal stroke, while for 7 being not 2, negative SLOTR also shows us the missing of the bottom stroke. Supposing that there exists a pattern set S in which the elements are in support of the decision towards or against one category. SLOTR is defined as a classifier that finds a subset of S that includes one or several patterns, and the decisions by SLOTR is solely based on the presence of the patterns, without using a black box classifier that makes the pattern set less interpretable. SLOTR is configurable to find either positive or negative patterns, the visualization of which can serve as the positive or negative explanations. Here is the pipeline of the SLOTR. Firstly, features are extracted by a CNN model. Then we replace the commonly used FT classifier with the explainable SLOTR attention module. Each category will get its explanatory regions and the sum of their area sizes, which is also the sum of the activation of the pattern set. Finally, the area sum goes through the softmax to find the category with highest confidence. This is the output of SLOTR, where the flat part is the sum of the explanatory regions and it is always non-negative values. The former part, E, is the switch to control the behavior of SLOTR. SLOTR will always try to make the output value of ground truth category as large as possible, which is close to positive infinity when E equals to positive 1. While keeping the output of non-ground truth categories as small as possible, which is close to 0. That means SLOTR will find as many as possible patterns for the ground truth categories, while preferring to find no supports for non-ground truth categories. On the contrary, when E equals to negative 1, SLOTR will find no patterns for the ground truth category, while finding as many as possible negative patterns for the non-ground truth categories. The SLOTR loss includes the cross entropy loss and the newly designed area loss, which is the total area size of the explanations. The area loss is used to limit the area size of the explanatory regions, and parameter lambda is used to adjust the importance of the area loss. Here are some visualization results for positive SLOTR. It gives reasonable and accurate explanations. Comparing with SSTEM and RBA, we can see that SLOTR can give explanations with more flexible shapes which fit the target objects better, for example, the long net. It also accurately finds the individual entities in the second row. A larger lambda decreases the explanatory region sizes. In the visualization results of negative SLOTR, we can see that it finds the negative patterns, for example, the water of the hen, and the hammerhead and the fin of the shark. Also, with the increase of lambda, SLOTR shifts its focus from some larger supports to fewer, smaller, yet still decisive supports. The quantitative results show that SLOTR has advantages in some commonly used metrics like IAUC, DAUC, in fidelity and sensitivity. This case study on glaucoma diagnosis shows SLOTR can give precise explanatory regions which have been validated by medical experts. In the intercategory visualization results, positive SLOTR successfully finds positive patterns for the images of ground truth categories. It also finds weighted supports for some categories with similar appearances, such as Y5 is 6, Y0 is 9, and Y8 is 9. While in the intra-category visualization, when predicting Y6 is 6, positive SLOTR always looks at the region close to the crossing point of the bottom circle and the vertical stroke, which shows high consistency. In the intercategory visualization for negative SLOTR, it gives some informative negative explanations for some visually similar classes, such as Y9 is not 1, and Y9 is not 7, and for Y6 is not 2, negative SLOTR always recognizes the presence of the vertical stroke and the missing of the bottom horizontal stroke. Thanks for listening. Please check out our full paper on arXiv and the source code on GitHub. Please visit us at RCCV 2021.